first one I got for you, diamonds. So I was at the wedding and I was thinking about
Diamonds are forever.
my future. I
Uh-huh.
was thinking about diamonds, you know. And while I was at the table, actually, I saw a PopSci article about diamonds. Usually, PopSci, I don't even read their articles because I'm kind of a hater of PopSci.
Oh,
I don't know why, but
you heard it here first, folks.
a few stories kind of rubbed me the wrong way. A few
Yeah.
headlines, I was like, whatever. But I read this one and I actually really liked it.
Okay.
So a story came from PopSci about diamonds, and there was two different headlines about diamonds in the news. I'm gonna come to you a little bit quickly with them, but here we go.
Hit me with it.
So there was two separate studies in both the journal Science and Nature, and they were both about inclusions inside of diamonds. So we're talking about diamonds that were made deep down in the earth, a couple 100 kilometers down, because diamonds require extreme temperature and pressure to form. That's what makes them so strong in the first place. And once they're super strong, what scientists actually look for is the inclusions inside of them.
What does that mean?
Yeah.
Exactly, yeah.
So an inclusion is something that would be dubbed an impurity. If you were to buy a diamond, it would be something that would discolor it or make it look different. And all it is, inclusion, it includes something in its crystal lattice structure. So instead of all carbons, there might be a little bit of one atom that's inside the middle that's included in the diamond structure.
Gotcha.
And even a little bit of one type of element can completely change the way it looks and what it is, and that's why they call it impurities.
So it's like a
Sorry, I'm just like waving my beer around.
no, that's okay. That's like a diamond pimple, you might say, like a little
Yeah, it's a
spurt
little-
of acne. It's like a little
just
little
stuck in the
blemish.
inside.
Yeah, okay, I got you.
So usually you don't want that. But what's interesting is that when the diamonds do trap something in it, they make their way all the way up to the surface, and because they're so strong, that the temperature and pressures at the surface allow the what's trapped inside the diamond to still be the way it was down in those pressures all the way hundreds of kilometers underneath the Earth's surface.
I see.
So here's the first one. Let me just get a few things actually. So yeah, the deepest hole I just have in reference, our deepest hole is 7.5 kilometers. So we don't really know a lot about what's that deep under the Earth, except for indirect things like this of diamonds bringing them up.
Got it.
So from the Science journal, there was a rare form of ice found in diamonds from China. It's called Ice 7. Go figure, I'm
Final
not sure
Fantasy
why.
Ice 7.
And last year, scientists made this kind of ice in a lab using lasers.
Okay.
And Ice 7, excuse me, is thought to be one of the most common forms of ice on other planets, like exoplanets, because they have way different temperatures and pressures, and a lot of them have higher pressures, and they think that the ice and the crystal ice form would be in this sort of structure. And now it's still ice, it's still frozen ice, it's just ice at a radically higher temperature and pressure, and as the water that was trapped inside the diamond rose up through processes of like mantle rising and maybe from a volcano came all the way up, that actual change in pressure causes the ice to freeze. So even at the surface, under room temperatures, you'll have frozen ice inside of a diamond because the diamond is so strong.
Even inside of a volcano. 'Cause
Yes,
I bet
it actually comes out of the volcano still with the ice inside of it.
That's insane.
Yes.
Because I bet a lot of people are thinking, how in God's name could there be ice inside of a place that is that
That
hot,
had a volcano.
right? Yeah.
So not really too much to learn from this one, but still pretty cool sort of studying the way water and ice react to different temperatures and pressures and maybe relating them to other atmospheres and things like exoplanets.
Yeah, dude.
So then the next one, coming from Nature, sort of the same thing. They're also looking at inclusions, but this time it wasn't water. It was something called calcium silicate perovskite. Now, this is a mineral that doesn't exist on the surface of Earth, but it's supposed to be the most abundant mineral, I believe the most abundant mineral in the planet, even though we don't see it here, because all the pressures within the mantle is where this would exist. And now they're theoretical. We don't actually have direct measurement that it is this mineral deep down in the earth. So this is another case where this mineral, the calcium silicate perovskite, was trapped within the diamond, and as it rose up, we were able to look inside the diamond and sort of get confirmation that yes, this was the mineral that was down there, that was included within the diamond, hundreds of kilometers deep down in the earth. and it confirms what we think about the minerals at those temperatures and pressures deep down within the earth.
Gotcha.
So two separate stories about diamonds, and I always started looking about diamonds because I was at a wedding, and then I learned about diamonds.
Yeah, right on.
Heck yeah.
I like that kind of stuff because I was just having this conversation with I think my friend Pat, but it's always fascinating to me like how we would ever understand what the
Interior of the planet.
what the interior of the Earth is about, because it's so hot and there's so much pressure and there's only so far we can dig. Actually, maybe I was talking to Chris about this. That like we'll never like reach the center of the Earth with anything. It's just impossible. Like there's no way for us to build anything out of any material that we know of that can withstand those temperatures and pressures, to go and investigate like firsthand. So we kind of have to rely on these indirect methods to
exactly
examine what's going on down there. So that's really interesting.
Kind of reminds me of that movie, the Core, where they send that stupid ship all the way down into the center of the Earth.
Yeah.
What's up, Lil Spud 5 joining the chat?
Yeah, Lil
what's
Spud.
up, man?
We're doing great. Good to see you here joining us. Lil Spud says the core we would melt.
Yes, we would.
Yes, we would.
And-
Also, Evil Pandas 231 says Ice Baby. I think that's in reference
Ice
to the
Baby.
classic song.
Yeah.
Ice Ice Baby. Dun 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 dun. dun.
And then my last one for this story is, so this calcium silicate perovskite is evidence of something called a mass recycling process.
Okay.
So when the crust that is at the surface subducts under another plate and it goes all the way down there, that's when all the crust would undergo these changes from the increased temperature and pressure that are deep down in the earth. And it would sort of you all right there?
Sorry, I just choked on my beer.
you would get a recycling effect of all that crust that gets put down and then reworked and remineralized into something different. And by actually seeing evidence of that, it helps the scientists better understand the process of the recycling of the crust within the earth and better understand how that all happens.
Cool.
So that's sort of where that study's going with that.
Interesting.
And that's what I have for you there.
Yeah, I like it. What do you think? Should we try to polish off these brewskis here?